In this series of videos, we're going to talk about trig form of a complex number. We will be able to write the trigonometric form, which is also called polar form of a complex number. And we'll also be able to go from standard form, which is what we're used to, of a complex number, to trig form. So we'll be able to go back and forth from one form to the other. Now, it's important to note that a complex number we can write as z. And a complex number z is a plus bi, where a is the real part and b is the imaginary part. The absolute value of a complex number is the distance from the origin. So the distance, an absolute value, a distance that a complex number is from the origin is the absolute value. So just like absolute value is distance from zero, the absolute value of a complex number is the distance from the origin. Now, in a previous class, when you learned about complex numbers, perhaps you learned how to graph them. If not, I'm going to show you the complex plane. The complex plane has a horizontal axis, that's the real axis. And it has a vertical axis, which is called the imaginary axis. These are not the x and y axes. This is a coordinate plane that is separate from your real plane. So that's the real plane, x and y. Your complex plane is real and imaginary, and they never intersect. So these two planes do not intersect with one another. When I graph a complex number, I am going to go left or right for the real part, and then up or down for the imaginary part. So, for instance, I could have an imaginary number, a plus bi, that lands in quadrant 1, and it would be a point. However, if I was looking for the absolute value of that complex number, it would be the distance from the origin. So we'd be looking for that length right there. Now that length is made up of two parts. It's made up of a real part that's horizontal and a vertical part that's our imaginary part. And horizontal and vertical lines make a right angle, so you can see this right triangle. We've got A and we've got a length of B. So it makes sense that the hypotenuse, which is the distance from the origin to the complex number, would be the square root of a squared plus b squared. So the distance from the origin is the square root of a squared plus b squared, and that's just using Pythagorean theorem. Okay, we're going to, in this example, plot a complex number and then find its absolute value. So when I plot, I'm going to draw a horizontal and a vertical axis. Horizontal is the real part. Vertical is the imaginary part. And negative 2 plus 5i will land in quadrant 2. Left 2, up 5. So its point is right there. So that's going to be negative 2 plus 5i. And the absolute value of negative 2 plus 5i is equal to the square root of negative 2 squared, which is 4, plus 5 squared, which is 25, and 4 plus 5 is 29. So the absolute value of z is equal to the square root of 29. Let's try another. Z equals negative 3i. The real part is 0. That would be the same as 0 plus 3i. I'm sorry, 0 minus 3i. So the real part is 0, which means from the origin we're not going to go left or right. And the imaginary part is negative 3. So we can tell right away when our complex number lands on an axis, the distance from the origin is extremely obvious that it's 3 units. You can still go through and say 0 squared plus negative 3 squared, which would give you the square root of 9, which is 3. Now, the absolute value obviously is going to always be positive because it's distance. Distance is always positive. Okay, here's one for you to try. Go ahead and press pause, and when you're ready to reveal the answer, come on back. Welcome back. The absolute value of 4 minus I, which lands in quadrant 4, right there, is equal to the square root of 16 plus 1, which is the square root of 17. Now in the next video, we're going to talk about the different forms of a complex number, and that's where we'll talk about trig form of a complex number.